A stock Tamiya 1/10 TT02 drift car can reach speeds of about 31 kilometers per hour. This speed is certainly fast enough to have a lot of fun drifting around with a car like this, but on this channel we like to push things to the limit. One of the most common upgrade paths for upgrading your speed is to increase the size of your gear on your motor side or reduce the size of the gear on the drive side. That's fast. Another upgrade path is to increase the battery voltage from something like a 2S battery to a 3S battery. Finally, the biggest speed gains are typically made by switching from a brushed motor to a brushless DC motor. But how fast can a Tamiya TT02 1/10 RC drift car actually go? Well, in this video, I take my R34 Nissan Skyline GTR, and we're gonna find out. Many crashes were endured on the way to reaching this top speed, but stay tuned for the whole video to see how fast we got it going. It's pretty remarkable. And while you're here, check out and subscribe to my channel. I make a lot of these cool videos and a lot more on the horizon, and it'll help me out a bunch if you subscribe and like the videos. Thanks. At first, I'm going to start by getting a baseline of my stocked brushed RC car versus a brushless Amazon RC car. I got this speed camera, can do 200K, and let's see how it works. I bought a Bushnell radar gun to track the speed of the RC cars, starting with my stock Tamiya TT02 drift car and then my brushless monster truck. Jesus Christ, that almost hit me. All right, 28. All right, hit 29. 29. Can you see that? Honestly, I thought it'd be a bit faster than that. So I need to explain a little of the math involved with this radar gun. Basically, to get a proper reading, your target should be coming at or away from you in exactly a straight line. Since I'm standing, the angle which I'm measuring at is actually about 15 to 20 degrees off of the horizontal, which is known as the cosine effect angle. Based on some trigonometry, the measured speed is actually a little lower than the actual speed of the car, as per this equation. After doing some simplification and assuming a 20-degree angle, the real car speed should actually be about 6.4% higher than the measured speed of the radar gun. It hit 29. Therefore, the 29 kilometers per hour in this run is actually more like 31 kilometers per hour. I'll continue overlaying the real speed going forward. Alright, now this smaller but brushless car goes. Oh, naturally we need the light on. Yeah, there we go. This thing is gonna whoop that. At first I wanted to get a baseline of the brush drift car and my brushless monster truck. I lost control of it a bit on this one and crashed into my camera. But what speed did I hit? 42! Look at the damage. 44. Good lord. Does it really go that fast? Holy sh. So to summarize the baseline, that's 31 kilometers per hour for brushed and 47 for brushless. Now it was time for the first upgrades. I bought the aluminum drive shaft from AliExpress for the TT02 chassis, as well as a 64-tooth wheel gear. You can see the assembly of all of these parts into my chassis. Got the right gears now. I also bought a set of metal pinion gears and installed the largest 29-tooth model. Okay, I got it meshing properly now, no grinding. With the gears and drive shaft installed, it was time to test it out. That's fast. The car immediately felt faster, particularly in the mid-range speeds. I ran a few runs to get a feel for the speed before getting out the radar gun to measure it. After a few runs, the max speed I measured was 32 kilometers per hour, which amounts to about 34 kilometers per hour when accounting for the cosine effect. So overall, about a 5 kilometer per hour increase in speed. Surprisingly not that much. And for your entertainment, this is the car when it lost connection to the transmitter and went max throttle uncontrollably. This crash smashed my front axle knuckle, which I managed to temporarily 3D print a new model of until the aluminum replacement arrived. Once I received the parts from AliExpress, I installed them immediately. You can see here the steering knuckles that I installed that are now aluminum. Next, I replaced the rear steering cups with aluminum parts for added strength. Finally, and most importantly, I replaced the entire steering column with metal parts and used the metal arm of the servo motor. This was important not only for strength, but also for the stability of the steering. I bought this brushless motor and ESC combo from AliExpress made by Rocket RC. This model is a censored brushless motor in a 540 size. I bought the 10.5 turn model that goes up to 3900 kV. The ESC is rated for 120 amps. Here's the motor, brushless, censored. You have to install the motor by soldering the leads onto the A, B, and C terminals of the motor. I actually had to go find some bigger soldering irons to get it to melt, since the heat sinking ability of the motor is actually really hard to make it solder to. Alright, put some grease on there, line it up a little better. I then installed the motor in place and the ESC in place, which are essentially a drop-in replacement for the brushed version that came with the kit. Then I booted it up for the first time. That's so much power. Alright, let's go try it out downstairs. So the crumpled tinfoil is important to reflect the waves, as a smooth surface will actually mirror it off. I noticed in my testing I couldn't pick up the vehicle at further ranges without it. Also, one remarkable problem with the radar gun is that when you're within a few feet of the car, it actually picks up the speed because of the EMI emitted from the electric motor. So basically, you have to read the car more than about 10 feet away to have a reliable reading. So here I ran my first brushless motor test, which immediately gave me a huge speed boost, although I was using the slightly smaller pinion gear just to be safe. You notice that the vehicle is a bit unstable. This is because I'm using that 3D printed steering cup that I haven't replaced yet. Yeah, 44 again. I was a bit limited by space here, but in my best run I managed to hit 47 kilometers per hour, or about 50 kilometers per hour when accounting for the cosine effect. At this point, I was finally able to make my brushed car go faster than the brushless car by essentially replacing the whole motor drive system to be the same as the brushless car. But that said, how much faster can it go if we increase the gearing and eventually increase the motor voltage to a 3S motor from a 2S? Let's find that out. In this test, I found more room to run and increased the pinion gear to 29 teeth from 26. Initially, I hit a speed of 55 kilometers per hour, and then actually managed to increase the run speed to over 61 kilometers per hour. I also ran into my car. For my final upgrade, I switched the battery from a 2S to a 3S LiPo. It was really hard to keep the vehicle stable at this speed because of two reasons. The first reason is that the steering has some slop and play, which means the wheels can kind of move a little bit when they're not supposed to. Secondly, at high speed, the R34 shell of the car acts as a giant wing, lifting the car off the ground and reducing traction. Jesus, that's fast. Now, with the higher voltage battery, I hit 67 kilometers per hour. Alright, so I changed the wheels to foam. I tried changing to foam wheels in hopes that I would get better stability, but as you can see, the stability actually just got worse. Finally, I took this car back to where I had the longest runway, and we're gonna see how fast can I possibly make this car go. This one's gonna be it. Ooh. 67. 67. Nice. And the leaves cushion the crash. So there it is. With all the upgrades, I was able to increase the speed from stock of around 31 kilometers per hour to over 71 kilometers per hour. With some aerodynamic tuning of the body to diffuse air from lifting the car, and by tightening up all the steering slop, in theory, I should be able to approach 85 kilometers per hour. But I'll have to save that for a future video. I had a ton of fun making this project, and I hope you enjoyed watching it too. Thank you so much for watching. If you like this video, please like it, please subscribe to the channel, and help me get this channel off the ground so I can keep making some awesome videos. I got some really cool ideas that you're not gonna wanna miss. See you in the next one.